Okay, everyone. So let's look at this worksheet where we're going to be doing a vector addition, but using this method, using the first method that you always learn whenever you do vector combination, which is the cosine law. Cosine law. Okay, so let's look at the first problem. So we have the following two vectors, and as I told you before, I've already added another sig fig. So they're all three sig figs, as you can tell. This one is three sig figs, three sig figs, three sig figs, and three sig figs. Okay, all right. So the first thing we need to do is to finish off the triangle. So that would be easy. All I have to do is just sketch the line from here all the way to here. Okay, so what we need to do first is to apply the cosine law. That's why the name of the method is the cosine law, to find the length of this vector right here, or of this length of this triangle. Okay, so the first thing is we need to find out this angle, or I should say actually this angle right here. So if I zoom in and I look at it, this angle, all of this is composed of three angles. The very first part is this part right here. The second part is this part, and the last part is this one. Well, the middle part is the easiest one, obviously, because this one is 90 degrees right here. It's a perfect corner, so it's a 90 degrees. Now for this part right here, this must be basically the complementary to the 63 degrees. So that means this one, let me just erase this one. So this part right here would be 90 minus 63, that will be 27 degrees. And as for this one comes from the Z, this Z right here, this Z, which means if this one's 38, this one is 38 as well. So this would be 38 degrees, which means the entire angle will be the addition of these three angles. So we have all this to be 38 plus 27 is 65, and 90 is 155 degrees. So now we start with the math, because we already also know this one as the length, and we know this one as the length as well. So the first thing is we're going to apply the cosine law. And whether you write ABC or not, it doesn't really matter. Uh, let's call this C, just to give it a symbol, which means this capital here, this one here will be capital C. And if we call this one A, that means this one here will be A. And if I call this one B, that means this one here will be B. Okay, so this one is the one that we need to find. So we write the cosine law as follows. So it is C squared equals A squared plus B squared minus 2AB, and then cosine of C. And then all I have to do is to plug in the numbers. So my A is 9.6 squared. I'm just writing in two sig figs now, but at the end I will round everything to 3. The other one is 5.4 squared. And then minus 2, 9.6, 5.4, and then cosine of 155 degrees. Now, whenever you have a cosine, just a cosine of an angle that's bigger than 90, so between 90 and 180, it's always gonna give you a negative cosine, which means you're always gonna get a plus here in its place. So basically, we will get the following. 9.6 squared, so 9216, plus 5.4 squared, 2916. And we know that this minus and whatever minus from here will definitely give me a plus. So I know eventually this will be a plus. And I'll prove it to you that this is a plus. It will be 155 with a cosine. See, there's a minus here, times 5.4 times 9.6 times 2 with a minus. And the answer is 9397. So the whole thing is 29. Yeah. So that means my C is the square root of all of this, which will be now taken to 3 sig figs. So I'm just going to square root this. I'll get 14.67 or 14.7. So 14.7. And no units because I didn't include any units in the original diagram. So this now is right here. That's it. This is the 14.7. So now time to what? Time to find the angle at the start vertex, which is this angle right here. Just this part. Okay. So this part will be A. So that means I need to use the sine law. So I do sine A over A, sine B over B, sine C over C. Now, if I know now all three sides, so I know check, 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 and I do know angle C right here, the 155, so I know this. And what we want to find is angle A. So it's this one that we want to find, which means technically this fraction is useless. I don't need it at all. So really what we're going to solve is sine A over A, which happens to be 9.6, must equal sine of C, which is the 155, but now divided by C, which is this one. So divided by 14.7, or you can go back to 14.67. I'd rather go back to 14.67, and then we have to cross. So I'm going to get A will be an inverse sine of the following fraction, 9.6 times sine of 155, and then divided by 14.67. So if I do this in one shot, right here, I will get um, 155 sine it times 9.6 divided by 14.67, and then you trig second inverse this with a sine, and you get 1605 or 16.1. 16.1 degrees, which will be just this part right here, just this part. Now, because we always have to relate to either north or east, I cannot just use this part by itself. I have to either relate to the north or to the east. So it seems that I can use the fact that I have the 38 just right here. And all I can do now is, if you think about it, add the 38 to the 16 that I just found. All of this. And that will have to do from the east direction. Okay, so it will be between east and north, which will be east-north, because we went east and then we went north up. Okay, so that means we will get a final answer to be delta. Oh, sorry, we have to add. So my angle will be, we'll do 16.1 degrees plus 38 degrees, which will be 38 plus 16 will be 54.1 degrees. So my final answer is going to be 14.7, open a bracket, square bracket always. It's going to be east, north. So east, north, east, north, and this thing, this angle goes right in between. And that's your final answer. Same idea, same amount of work. The first thing we're going to do is insert the line in between the beginning and the end. Okay, so now what we're trying to find is the length of this vector right here. So we do the same thing. We know this length, we know this length. We just need to find this whole angle, or again, this angle, sorry, this angle right here, from here to here. Well, let's look at the parts of this angle. If this is 47, if this right here is 47, that means this one is 90 minus 47, which is 43. And for this one, we have to use the Z. So for example, we can use this Z. Look, the Z here, this, and this, which means this must be 82 degrees as well. So the whole angle, all of this angle right here is 82 plus 43. 80 plus 4 is 120, so that will be 125 degrees. Okay, so again, we'll proceed with the same way again. So I'm going to call this one C, which means this is C. I'm going to call this one A, which means this is A. I'm going to call this B, which means this is B. So C squared equal A squared plus B squared minus 2AB cosine of C. I can do it on the same line. A happens to be chosen to be 24.2. This one is 34.2 minus 2. A is 24.2 again. This one is 0.2 cosine of 125. Well, that means C squared is equal to, that means my length of the vector is the square root of this value, which is 52.006, or to 366 52.0. Now we need to find this angle right here. First, we need to find all of this angle. All of this angle. Okay, so I need to do again the same thing as before. Sine A, sine B, B, sine C, C. Well, we always know that we got the three lengths by now, and the angle I know is this one, so it's angle C, and the angle I want to find is angle A, which means again B happens to be the useless fraction. Obviously, any fraction could be the useless fraction, depends on how you label your ABCs, okay? So far it's happening to be the B's. So now I need to plug in sine of A, which I need to know, over A, which is 24.2, equals sine of 125 divided by 34, no, sorry, divided by the 52. But now I'm going to go to 52.1, because 6 will bump up this to a 1. So 52.1, just to get the more accurate answer. So cross, which means A will be sine inverse of 24.2 sine of 125, and then divided by 5201. Okay, now this 22.4 is this part, all of it. Okay, well, if we erase this red line, and since I just want this part, I could do an easy thing of what? Taking all of this, which is 22.4, all of this 22.4, and then just subtract this part right here. Just subtract this, sorry, this part. Just subtract this part right here. Right here. Well, this yellow part is 8 degrees, as you can tell, because if this is 82, then the part above it is just 8 degrees. And that will give me this part. That will give me this part right here. So I can do on the side, I can do 22.4 degrees, take away 8 degrees, I will get 14.4. So that will be what? That will be this part right here, which is also happening to be northeast. Sorry, east-north. East-north. So my final answer is delta D equals 52.0 bracket east north, and it's 14.4. Okay, now let's go to the second page. Okay, we need to connect the start to the end, because we went this way and then we turned and then went this way. So we need to connect these 2 points right here. So what we need to find is the length of this vector. So we need to find this angle because that's the angle between this vector and this vector, the ones that are known. So to find this angle, well, this is 41 right here. So to find this angle, we can use this angle right here, and from the Z, um, this is 19, and my Z is right here. This is my Z. So that would mean that this is also 19. So if this is 19 and this is 41, this right here will be 90 minus 19 minus 41, because the whole thing adds up to 90. This whole corner adds up to 90. So that's equal to, well, 41 and 19 is 60. That's exactly 30 degrees. So now we're ready to label. So let's call it A, B, C. That'll mean this one's C, this one's A. So this one we actually, in this one we're gonna find B. So let's write the cosine law. So B squared equal A squared plus C squared is 2AC cosine of B. So the square root is 431. And so that is right there, right here. So now I do the sine. So sine A over A, sine B, sine C over C. So let's check which ones we have. Obviously, again, we have all the lengths. Now, which angle do we know? We know B, and we're trying to find C, because everything started from C. So this is the one we're trying to find, which means A now happens to be my useless fraction. So sine of B was found to be 30 degrees, and the length of B we just found to be 431. Sine of C is the one we're trying to find, and C was 678. So cross, you'll get C equals sine inverse of 678 sine of 30, all dividing by 431, 51.9 degrees. Now, if we look at this, this is an obtuse angle. So practically, C is not 59 degrees. Angle C, is actually 180 degrees minus 51.9 degrees, which will be 129.1 degrees. Okay? So the question now is, how do you find the angle right here? Everyone, we just need this angle. Let me zoom in. We need this angle. Just this part. Just this part. Okay? Well, if you look at it, this part, all you need to do is take this whole angle, the whole C angle, and just subtract this much and this much. Okay? So you need to subtract 19 and 90 from the full angle C. So that means, let's do it here, 129.1 degrees, subtract 19, subtract 90 will be what? So that means my final answer is 431. Now what about my angle? Well, if you look at your angle is right here, which which is west, and then you went north. It's in the northwest direction. It's in the northwest quadrant, but because it has a base on the west, it's west north. So your final answer is west north, and we just established it's 21.1 degrees. And finally, the fourth one. Okay, so what we need to find is this length right here first. So since we know this one and this one, this is the angle we're trying to find, or again, this angle right here. So if I look at this angle closely, um, there's a Z here. This is the Z, which means this part right here is 42. This part right here is 42. And this very small part, of course, it has to be 4 degrees because that's the complementary to the 86. My full angle is all of this, which is just 46 degrees. So now we're ready for the application of the cosine law. So, oh, we have to label. So let's go with A, B, C, which means this is B, this is A, and we need to find C. So C squared equals A squared plus B squared minus 2 AB cosine C. So it will be, which will mean that C is equal to the square root of this guy, which is 38.9. Okay, so that number will be um, this right here. So now to find the angles, sine A over A, sorry, sine B over B. Now which one do we find, or do we know? Of course we know the A's, B's, and C's, the lengths. Now which angle do we know? Well, we use C, so we have it. And the one we're trying to find is from here to here, so that will be the angle B. So we need to find this one. We know this one, we need to find this one. So A is my useless fraction. So sine B is, with the one we're finding. Length B is 47.4. Sine C is the 46. And length C we found to be 38.9. So criss cross, we get B equals sine inverse of what? Of 47.4 sine 46, 38.9. Now, if you look at this angle, this is not 61.2. It's an obtuse angle. So that means this angle is actually 180 minus 61.2, which is 118.8. Yep, 180 minus 61.2 is 118.8. But we just want this part. We just want this part right here. Well, if you think about this, this part, here's an easy way to find the whole thing. Look, this whole thing is a protractor. So this whole thing is 180. Well, this is already covering 42 degrees of it, of the 180. This is covering, as we just established, is covering 118 out of it. So this one will be just the 180 minus 42 minus 118. So 180 minus 118 minus 42, which will be 180 minus 118.8 minus 42, which is 19.2. Okay, so my final answer is delta D equals 38.9. Now it's 19.2, but we need the directions. If you look at the angle, the yellow angle, look at it, it's between west and north. Okay, it's between west and north, which means it's west-north the way it's shown. So it is west-north. And that's this worksheet.